Okay, hi everyone. This is part of my video series on general chemistry, and this video is going to cover polyatomic ions. Let's begin with some definitions. A polyatomic ion is a covalent molecule that has a net ionic charge. The charge of a polyatomic ion is spread out across the entire molecule. Oxyanions are a subset of polyatomic ions that contain oxygen and only one other element. All oxyanions have a negative charge, and most polyatomic ions are oxyanions. Another thing to define is common oxyanion. Common oxyanion means the oxyanion that is most common for a given element to make. In many cases, an atom can make different oxyanions, each with a different number of oxygen atoms, but one will be more common than the others, and this is called the common oxyanion. For example, the common oxyanion for nitrogen is NO3-. This is the common oxyanion because nitrogen most commonly makes an oxyanion that has 3 oxygens, but it can also make NO2-. The common oxyanion is named by taking the name of the non-oxygen atom and adding the suffix -ate. So in this case, it would be nitrate. Would be the name of this common oxyanion. Here are the 7 common oxyanions that I would know by heart for any chemistry class. We have carbonate, nitrate, phosphate, sulfate, chlorate, bromate, and iodate. Knowing these common oxyanions by heart will be very beneficial. It might be daunting at first to memorize all the numbers associated with these common oxyanions, but here are some patterns and tricks to help you memorize these. You should group carbonate and nitrate together because carbon and nitrogen are both from row 2 of the periodic table. Their common oxyanions both have 3 oxygen atoms, so add 1 to the row to get 3 oxygen atoms. Carbon comes before nitrogen within row 2, so it gets a 2- charge to match row number 2. And then if you add +1 to that, you get -1 for the nitrate. You should also group phosphate and sulfate together because phosphorus and sulfur are both from row 3. Their common oxyanions both have 4 oxygen atoms. Phosphorus comes before sulfur within row 3, so it gets a -3 to match row 3. Then if you add 1 to that, you land at the -2 for sulfate. For the halogens, chlorine, bromine, and iodine, Their common oxyanions have 3 oxygen atoms and the charge is -1. Those are easy to group together. You just have to associate them with 3 oxygens and a -1 charge. So those tricks are useful to me, and hopefully they will be useful to you as well and help you memorize the common oxyanions. Next, we will talk about naming non-common oxyanions. Many of the common oxyanions can be altered by taking away or adding more oxygen atoms. When we do this, the name of the polyatomic ion changes. Here are the rules for how the name changes if you add or take away oxygen. If you add one more oxygen to the common polyatomic ion, you add the prefix per. If you take away one oxygen from the common polyatomic ion, the suffix changes to "ite". If you take away 2 oxygens, you add the prefix hypo, and the suffix remains as "ite". Not all elements that form oxyanions will be able to make 4 different ones. If you memorize the common oxyanions and this naming pattern, you should be able to name any oxyanions that the atom can make. So I would recommend remembering the common oxyanion roots, and I would recommend memorizing this naming system. And given those 2 things, you should be able to figure out any question that could be asked of you. Chlorine is an example of an atom that can make 4 oxyanions. The charge is constant even though you are changing the number of oxygens. This is true for all the different variants of a given common oxyanion. The charge does not change with the number of oxygens. Let's go ahead and name all of these. The first step is to identify which one is your root. The root is this one because we know all the halogens have a common oxyanion with 3 oxygens. So this is chlorate. And then if we add 1 oxygen, then it becomes perchlorate. If we take 1 oxygen away from the root, then it becomes chlorite. And if we take 2 oxygens away from the root, it becomes hypochlorite. Let's do nitrogen as another example. Nitrogen can only make 2 different oxyanions. The first step is to identify which one is your root, and that would be this one. So that one is going to be nitrate. And if we remove 1 oxygen from the root, then it becomes nitrite. Again, if you memorize the common oxyanions and the naming system, then you should be able to piece together any question that you could be asked if you know those 2 things. There are a few important polyatomic ions that are not oxyanions. Ammonium is NH4+. Ammonium is the only polyatomic ion that has a positive charge. Next, we will talk about ionic bonding of polyatomic ions. Since polyatomic ions have a charge, they can make ionic compounds with metal atoms. But keep in mind that within the polyatomic ions are covalent bonds. To create an ionic compound with a polyatomic ion, we have to find the ratio that leaves a neutral overall charge. Because remember that an ionic compound must have a neutral charge by definition. I've written out some examples to try here: calcium carbonate and sodium sulfate. So we know calcium is in group 2 of the periodic table, so it likes to get rid of 2 electrons, which leaves it with a 2+ charge. Because we're getting rid of 2 negatively charged electrons, that leaves us with an imbalance of protons to electrons. And we know carbonate is going to be CO3 2-. We can combine these in a 1-to-1 ratio to create a neutral charge. And that would be the ionic formula for calcium carbonate. Let's do the same for sodium sulfate. So sodium is in group 1 of the periodic table. That means it likes to get rid of 1 electron. That leaves it as Na+, and then sulfate is SO4 2-. Now we have to find a ratio that leaves us with a neutral charge. The easiest way to make that work is take 2 of these and take 1 of these, and that leaves us with Na2SO4, and that would be sodium sulfate. Let's do another example. So calcium, just as before, is going to lose 2 electrons and become calcium 2+, and we know chlorate is ClO3-, and we have to find a ratio that gives us a neutral charge. The easiest way to make that work is take 1 calcium, and this time we are going to take 2 chlorates. And in cases where you need more than one of the polyatomic ion to make the charge work, you need to use a special notation. The polyatomic ion is written in parentheses with the number of the polyatomic ions written outside the parentheses. So in this example, it would be Ca parentheses ClO3, and then a 2 outside of the parentheses. And this is saying that we have 2 of everything within the parentheses. Ionic compounds between metal atoms and oxyanions are named by combining the name of the metal atom combined with the name of the oxyanion. No prefixes would be used because remember that prefixes go out the window when naming ionic compounds. K2CO3 would be potassium carbonate. Here's a more tricky one. Sulfate has a -2 charge, and we have 3 of them, so that's going to be 6-. And iron is a transition metal that can have different possible charges, So we need to specify which type of iron we are dealing with. We know that the overall charge of the ionic compound must be neutral. Therefore, the ions must be contributing 6+, and if we have 2 of the irons, that means each iron must be 3+. So we would name this as iron with a Roman numeral 3 to specify we are dealing with the version of iron that likes to get rid of 3 electrons. And it would be iron 3 sulfate.